Uh, Good afternoon or good morning, depending on where you are. My name is Neil Abercrombie, and welcome to our PMAC session today. So, if you're having any technical issues, please open up your Q&A, and our host will hopefully be able to assist you. You can find that feature at the bottom of the presentation window within FeedLoop, and we'll be conducting a Q&A session at the end of the presentation. So please type any questions that you have into the chat function of FeedLoop, and we'll pick those up at the end. You can click on the top corner of your window to maximize the presentation, if that's helpful to you. And if you have any additional questions or comments for the speaker, please feel free to put those into the chat function. So without further ado, I'm going to hand across to John, and John will introduce himself through the session. So thank you.
Hello, my name is John Lambert. My presentation today is on the importance of precision maintenance and how it will greatly affect the industrial Internet of Things. I'd like to give you a little background on myself. As I said, my name is John Lambert. I did serve an apprenticeship in Liverpool in England many years ago. I've held many positions. I've been a millwright, maintenance mechanic, a foreman, a supervisor, a training instructor. I was trained in reliability-centered maintenance as well as total quality management, and I implemented that into the engineering in the company that I work for. In 1994, I started my own business, Benchmark Maintenance Services. I specialized in rotating machinery. Our main claim to fame is the training that we have done. We have trained literally thousands of tradesmen in lots of industries, including Dofasco, Ontario nuclear plants, and many more. It's been good to me, the trade, so I like to give something back. So I'm on the advisory board of the apprenticeship program in Durham. And if you would like more information, I guess it's all there for you to read. The industrial Internet of Things. Is this the next big thing? Well, yes, the sheer volume of the data that it can be controlled and analyzed by the different parameters that it can monitor make it a must-have. Will it live up to the hype that surrounds it? No, it won't. And there will be a lot more hype. The question for me is, will it work? Will it do what you want it to do? Let me state my case. I'm all for improving the maintenance processes, and the industrial Internet of Things will do this by improving the monitoring capability, your monitoring capability. However, what it will not do is prevent failure. My presentation today will build the case for what you will need to have in place, what you need and for the industrial Internet of Things to be successful. Before I get there, please take note of my email address so that you can email me any feedback or ask me a question after the fact. Maintenance has evolved. They say to know your future, you must understand your past. Let me point out some of the steps that we have taken in our evolution so far, our past, if you will. And please understand that due to the time limits, This is only a drive-by. In my day, I started out with reactive maintenance and preventative maintenance. Reactive maintenance was run to failure maintenance or breakdown maintenance or firefighting, call it what you will, but we all know what it was, and sadly to say that it is still commonplace today. Preventative maintenance, which I liked because it gave a structure and done right, it did what it was called and prevented some failures. But I admit it was the first thing that we dropped when things got busy. But then the new technology was developed, vibration analysis, or should I say it became more available. This technology could find the elusive fault, the potential failure. It was the vibration instrument companies that ushered in the strategy called predictive maintenance, surrounded by hype, which led us to believe that it could do just about everything. Not unlike the hype that surrounds the industrial Internet of Things today. The mantra was, if you are not doing predictive maintenance, you are not doing maintenance. What that did was make past tense of preventative maintenance. The point was made that preventative maintenance was over maintenance because we opened machines up to examine them, which back in those days was true, but not now. Predictive maintenance is the new maintenance, said the hype. In my opinion, we blew it with predictive maintenance. I believe that maintenance evolves. It's constantly changing in regard to these basic maintenance strategies, an ebb and flow, if you will. As you can see, I have added condition-based maintenance and proactive maintenance. Although not new to me, it was back in those days. Maintenance evolves, moving forward with new technologies and process changes. And sometimes it moves back because of a lack of training on a new instrument or on a new process. Or a reduction in staff can make a huge difference. To be proactive, you may be in the proactive mode 1 week and then slip back into the reactive mode the next. For me, proactive maintenance using breakdown analysis along with condition-based maintenance saved the day. The reason I'm showing you all of this is we still need these basic strategies and more as we continue down the road of maintenance. Proactive maintenance. Actually, with predictive maintenance, we focused and fixed the fault. If we found a bad motor, we replaced the motor. It didn't matter if it was a lubrication issue, a broken rotor bar, or an inner race. We replaced the whole motor. However, proactive maintenance moved us away from focusing on the fault. Asking the question why was our first starting point. It was said that asking the question why 5 times would lead you to the problem or the cause. Sounds easy, but it's not. One important point is that you might have the right questions, but you need to get the right answers in order to find out what the problem or the cause is. And that would be the correct, honest answers, which is not always easy. A definition of insanity is to do the same thing over and over and expect a different result. If we keep replacing bearings and don't figure out what's causing the failure, are we crazy? Again, with predictive maintenance, we focused on the fault. If the bearing was at fault, we replaced the bearing. The bearing was the effect. We needed to find the cause. Proactive maintenance introduced us to root cause analysis, which is cause and effect. Being proactive is more than just doing maintenance. It's doing the right maintenance, which is fixing the cause forever rather than forever fixing the effect. Root cause analysis using a fishbone diagram is a skill that many still have not mastered. And it's critical, and it is a critical part of the maintenance process. If you actually wanted help with that, our Susan LaBelle or James Rees-Picknell or James Kovacic could definitely help you with that. Selecting the right manufacturing tools. All of the basic maintenance strategies programs that I just discussed with you are still featured in some form in these structured maintenance programs. The difference is you pay for them when they're in a program. Ron Moore, author of Selecting the Right Manufacturing Tools, Improvement Tools, well, he called these programs tools, and he published a list of 75. This is just a sample of them. But let me ask, how successful are they? Do they work? Do you see the numbers? I am told the failure rate for these programs is as high as 70%. Why is that, do you think? I took reliability-centered maintenance, and my task was to implement it into the engineering and maintenance department in the plant that I worked at. RCM2 by John Mulberry was the big one, or maybe is the big one. It sure gets the most attention and the most ink in my day. The problem with these programs are they are hard to implement. They take a lot of resource time, man hours for training, etc. And if you have a plant to run, you can get short of man hours very quickly. These programs do work, but you may not have the resources, the people, to do it all. But even if you can't do it all, you can still do parts of the program that is easier for you to implement. I think of the fact that I have Microsoft Office, but I don't use all of it. But I use what I need, and you can do the same with RCM. What the training taught me was the benefits of understanding the P2F interval curve, as well as the great benefits of root cause analysis and condition monitoring program. Mulberry called them on-condition tasks or on-condition maintenance because the items were left in service on the condition that they met the desired standards. On-condition maintenance, he said, includes predictive maintenance, condition-based maintenance, and condition monitoring. And you can read that on page 14 of his book. That book by the way is a photograph of my original copy. This is the P2F interval curve. This is condition-based maintenance, and it's what the industrial Internet of Things will be. We use predictive maintenance techniques such as vibration or ultrasonics, thermal imaging, etc. The sooner the potential failure can be detected, the longer the P2F interval. The longer the P2F interval means more time for you to take action. The earlier the detection usually means a more sophisticated instrument, think expensive, with no guarantees that you will get more time. But in most cases, you will. Condition monitoring does work, and it's simple. It's cost avoidance, and it's cost saving. It's a win, but it will not prevent machine failure. This is a reliability-centered maintenance study, case study. Why do we still have breakdowns? This is a question that was asked of Doug Plugnetti of Reliability Solutions. The question was from an organization that had been applying vibration analysis, predictive maintenance to over 800 assets for 3 years. They were successful at finding point P, potential failure, thus saving downtime, but still having assets, machines, go into alarm. Okay, quickly, Doug Plugnetti is a reliability-centered maintenance practitioner, trainer, mentor. He has performed RCM analysis for companies around the world, a guru, if you will. If you were into reliability, I'm sure you will know who Doug is. He is all over the reliability web and LinkedIn. But this is his email if you want to reach out to him, and he's even supplied his phone number. So if you feel the need, contact him. Again, the question was, why do we still having breakdowns? Before he answered, a reliability-centered maintenance analysis was done. It identified 140 different failure modes, including misalignment, soft foot, pipe stress, lack of lubrication, cracked foundations, improper belt tension, improper design and application, and on and on. All the failure modes on the list covered in the organization's RCM analysis had two things in common. Each one could be eliminated through either a simple redesign or better maintenance installation practices. As a way of explaining it to his customer, Plocknetti Reliability Solutions added the I for installation and the D for design to the P2F interval curve, as you can see on the screen. He correctly pointed out that all the problems that led to the potential failure and eventual failure were under the D and the I. What does this mean? Well, Plocknetti says, while a large percentage of reliability efforts are focused on detecting point P, the truth is, if the organization simply did the right thing first, point P would very rarely rear its ugly head. This is not rocket science. Most of us that were in the machine installation business knew this. But Doug was the first to articulate it, so kudos to Doug. But look at this graph. You can see condition monitoring is on the right and preventative maintenance is on the left. And simply put, if you do D and I right, you can push P and F very far to the right. In my experience, there is very little redesign work done in comparison to the poor installation work. I can even put a number on it. I would guess that it's 10%, especially in an oil plant. But even if I said it was 20%, that would mean installation is 80% of your problems. So the low-hanging fruit for us all is in the I, which is installation. Looking for P, the potential failure, is condition-based maintenance. I is preventative maintenance, and an ounce of prevention is worth a pound of cure. The installation is the problem, and the fix is a two-part process. Part one, precision maintenance is a method of performing maintenance tasks so that they are always done with consistency, accuracy, and to a known standard. I'm actually going to read that again. Precision maintenance is a method of performing maintenance tasks so that they are always done with consistency, accuracy, to a known standard. It means to work to a set tolerance that you and your team agree on. The tighter the tolerance, the better the result. But you cannot have a tolerance that you cannot measure. Most importantly, it's commissioning to a standard and documenting the process. The answer to the question why we asked in proactive maintenance is usually found in precision maintenance, doing it right. But don't overthink this. It simply means doing the job right. Most of us know what's right. We use the standard to give us a tolerance that we need to work to. Okay, the problem was, especially in my day, is that we didn't have a standard for this work. There were standards for vibration levels and balancing standards, but no machinery installation standards. There were general industrial guidelines or rules of thumb, like the American Petroleum Institute API 686. However, there are no recognized standards similar to an ANSI standard or an ISO standard until 2017. This is the first shaft alignment methodology standard in the world. It was recognized by the American National Standards Institute and the Acoustical Society of America. It was commissioned by the Vibration Institute and came into being in 2017. Not a lot of people are aware that it even exists still today. But if you are interested in getting this and want some information on it, by all means, email me and I'll make sure that you get the information. Just to give you some quick hits on this, the standard is written with specific recommendations and must-dos. A must-do is thou shalt. But it's not a how-to-do book. It does give guidance. For instance, the standard has a flowchart for machinery installation, which is a recommended guideline, but it's not a must-do. The base is critical to machinery installation. Base pads and foot pads need to be measured for flatness and coplanar,ity, and the whole base needs to be leveled. And you can see that there are tolerances for all. Let me ask you a hypothetical question. Do you measure the bases for flatness of your machines? Interesting. It even covers things like shims. You would not believe what I have pulled out from under a machine's foot. We know that we need to cover 80% of the machine's foot. We also know that you can only use a maximum of five shims. But do you know that we should be measuring all shims that are over 20 thou? The reason why is because you don't always get what you see. It's stamped 125 thou. It actually measures 115 thou. So you don't always get what you see. This is something that is not really done. We're taking a rim reading and a face reading on a coupling hub. We're measuring the runouts on the hub. The top is the rim and it's hardly moving. The side is the face and it's moving 5 thou. This will kill the machine. And appropriately, we have a standard for that. And if you're installing a large piece of machinery, you would want to get this under 1 mil, which is 1 thou. Precision maintenance installation, for a precision maintenance installation, you need to cover and document all these items that are listed. But remember, Rome wasn't built in a day. So you can just do one machine at a time, but install or reinstall it to the best of your ability. And that, ladies and gentlemen, boys and girls, is the first part of the fix. Part 2 of the fix is documentation. Computerized maintenance management systems greatly contributed to the evolution of maintenance. It gave us order, structure. It contains or should contain many records, reports, machinery, history files, etc. One record that is a must is the installation and commissioning report. Do you have such a report? This is big. Imagine you want to do a breakdown analysis and you do not have a written report of the last installation. You would be only guessing about what happened during the installation. If I ask a tradesman, a year after he did the job, did you align those shafts to within specification? What would you expect him to say? When I was on the tools, I would have said, yes, I did. But can you be sure? Can you make a decision on guesswork? This is big. This is what brings proactive maintenance down. The inability to find the fault, which means you are forever fixing the effect, not the cause. To make precision maintenance and documentation work, you need openness from all who are involved in the report. You need everybody to learn from this report. So you need the good and the bad in it, all the warts on show, and integrity, the practice of being honest. Because without it, you are guessing again. What you don't need is politics, cover-up. Politics is usually someone else's agenda, and cover-up usually means you are protecting the individual or the team. None of this helps. You need a team approach because precision maintenance is a team game. That does not mean you have to love each other, but you're all in it together, so you might as well pull in the same direction. Pointing fingers helps no one. If a tradesman has never been shown the correct way, who should be responsible? The frontline supervisor or the department's head? I love this. This is eye candy to me. This is Primac, an expert company in Western Canada in machinery failure. If you look at the arrows, the motor is moving up and down, yet the base is moving left to right. So you can see it's way out of sync. You can see these videos, they're commonplace on LinkedIn and YouTube. And the vast majority of them point to the fact that the installation is the biggest problem. It's not new. People who understood vibration knew this all along. But with motion amplification, now us mere mortals can visually see and get a better understanding of what's going on. So it's not a figment of my imagination, and it's not even the artificial intelligence. It's basic intelligence. Look at what's in front of us. Why did the strategy of predictive maintenance fail? Well, it never had a chance. We had the cart before the horse. And unless you can teach this horse to steer, this cart's going nowhere. Don't get me wrong. I love the technology that it uses. The machines were already at point P when we started. And that was due to the fact that we had done a very poor job of the installation. Many maintenance programs struggle with implementation. They get nicknamed the flavor of the month, and they drift off into the night. I believe that the reason for this is they never really truly involve the people that matter, the guy on the wrench. Implementing a precision maintenance program needs their involvement, otherwise it fails. This is a team building exercise that is not easy. The industrial Internet of Things has huge potential in the field of condition monitoring. It can be your eyes using cameras, even infrared cameras. It can be your ears using ultrasonics and so much more. However, you've got to give it a fighting chance to be successful by making sure machines, assets are in the optimum condition before you start measuring and monitoring. To wrap it up, I would say that there are 3 things that will improve your installation processes and by extension, your maintenance processes. And they don't cost you an arm and a leg. 1, start a precision maintenance program. Work to a standard. Get rid of the mindset that says close enough is good enough. 2, keep detailed documentation on your machine assets. This is key. If you seriously want to improve your maintenance efforts, this is a must. 3, continue proactive maintenance, condition-based maintenance, with an emphasis on machine failure analysis. It is your choice, forever fix or fix forever. Have a plan that you all agree on. This includes accountability for all, not just lip service, but tradesmen, frontline supervisors, and managers. There is no bolt of enlightenment that's coming out of the blue to fix this. There is no silver bullet. We have to look at what's in front of us. Thank you for taking the time to see my presentation. And please take the time to email me any questions or feedback that you may have. and please stay safe, be well. Thank you.
Well, thank you very much, John. That was really interesting. Like, you covered quite a lot of ground there. It was great to learn from like some of your practical experience. So if there are any questions, please type them into the networking tab of FazeLoop, or you can put them into the chat area, and we'll see them there. So please do that now. We've got another 15 minutes. So while we're waiting on questions from our participants, so I'll start things off. So like you talked a lot about the importance of like a documentation, like during the installation process, and documenting that well. In your experience, like what does a well-managed set of documents look like?
Interesting. The slide that I had on there was it showed a KSB installation. They design and install pumps for a lot of customers. Their documentation is at least 3 pages long, and it covers it all, including the installation. So you really do have to make sure that you've got from step 1 all the way through to starting from the base all the way through to pushing the button to start the machine. You really do have to make sure that you've got everything recorded. So I can't give you you know, what one would look like. I can actually show you the documentation that the standard recommends. But it's all the average stuff: shaft to shaft alignment measurements, soft foot, all these sort of things. Okay,
thanks very much, John. We've got a question here from James. Where does one start with the precision maintenance program, and what's the low-hanging fruit? For example, alignment, flatness, etc.
The case study that I showed, they did an RCM analysis, and it pointed out 140 different failure modes. It's those failure modes that we have to capture, and it includes it all. So if you actually follow the standard, it begins with the base. So the base has to be flat, not crowned. It also has to be collinear within 2 thou, which is a very tight tolerance. If that isn't flat, coplanar, you distort the casing of the machine. If you distort the casing of the machine, more often you distort the bearing housing, and eventually the machine's going to fail. However, so that means it's critical to actually start with base flatness, and then you build from that. After you've done the flatness of the base, you install the machine, you check it for soft foot, and then you move step-by-step process into shaft alignment and make sure that they're into alignment. The new standard actually has 3 levels of standard. It's not all precision, but obviously the tighter the tolerance that you can actually get, the better it's going to be for the machine. And so the whole standard actually points out what the process is for a precision maintenance program.
Thank you, John. A question here from Gabrielle Dougal. So it's about motion amplification cameras. So it's a kind of new technology that's kind of come to the market in the last few years. So apart from producing lots of very scary like videos, like how do you see motion amplification being applied in the future? And is that something that you would encourage maintenance practitioners to investigate?
I actually find it very interesting. I called it eye candy. Yeah, there are some scary things. So it's something new that allows us to see very small vibrations. And it looks scary because like we're amplifying it. So it's a distortion really of what the vibration is. So we're magnifying it, we're making it look massive, but that's just so that we can recognize it and see what it is. When I actually mentioned before that it's nothing new, people that have vibration instruments know that there's a different vibration reading from the motor than there is on the base. So I like the technology because it gives everybody a visual, and I'm a very visual person. I like to be able to, when we train using visual support. And I like this. However, as I said, it's not a critical thing that you need. If as long as you've got vibration, you're going to basically, get the same thing. However, it will enhance any service provider's toolbox, as it were, such as Primac. They're a specialist in machinery installation and vibration monitoring. They use it to be able to go and show their customer, so it gives a better explanation to their customer. So it's great for the service industry.
Great, thank you. So, like you mentioned, the Internet of Things, like briefly. So that, like, the Internet of Things it can seem like a bit of a sweetie shop for designers and maintenance professionals. Like, what advice would you give, like those people who have their hands in the sweetie jar at the moment?
Yeah, well, actually, it's got huge potential. It really does. The key is, obviously, you're going to want to make sure that you control the data that's coming in. You don't want all the regular stuff. You only want, the things that are out of the norm. But the key is, for me, you've got to make sure that you're measuring the correct parameter. So if I was designing a system, let's say, for instance, can't think of anything off my top of my head, but if I had a very low-speed gearbox that I wanted to monitor, I would probably use ultrasonics because it will give me a better return on the investment rather than vibration if it's a very slow-moving gearbox. But to counteract that, if I had a high-speed one, I'd be definitely using vibration rather than ultrasonics. So I'd have to make sure that I measure the correct parameters. I know one that's getting popular is infrared cameras being fixed, and so they can detect the heat, see how a machine's operating. But I best leave it at that. Make sure that if you are actually got the hand, you've got to go and buy something, make sure that it's the parameter that you really want to measure.
Thank you. Okay. Well, thanks very much, everybody, for your involvement in our conference. So just give you a reminder that we're having these sessions as a lead up to PMAC's MainTrain sessions in a couple of weeks' time, which are on the 28th and 29th of September. So please encourage you all to attend that conference, and please share that with your colleagues and friends. There'll be a tremendous amount of great content in that conference. So just before we finish, I've got another question here from Gabriel. Gabriel, do you think that ANSI standards for shaft alignment and machine installation should be implemented in any plant wishing to reach a higher level in terms of maintenance?
That's a great question. Yeah, the answer is yes. To be perfectly honest with you, I think the new standard should be right now in all colleges. All apprenticeship colleges, and any company that wants to improve their installation or their maintenance process, it's $150. It's the best thing you'll that you can go and invest in. Without a doubt, the installation is the key. If I was a design engineer and I designed a piece of equipment, I'd want to make sure that that piece of equipment was installed correctly, so that I get the full life expectancy out of it. You can have the best piece of equipment, the best design that's available, and if you put it in incorrectly, it's going to fail prematurely. And then who will they look at? The installation or the design? Unfortunately, we look back at the design. So make sure that you have a copy of the standard if you're a designer, and make sure that you have it, these parameters that need to install it to this standard.
Great, that's a great tip for people to check that these standards are included in design specifications when you're creating projects. Okay, so if there are no other questions, I'd like to thank John for his presentation today, and look forward to seeing you all at MainTrain in 2 weeks' time. So, thank you very much.
Thank you.